We've got a case on our hands. Mysterious exoplanets, and we need to profile them.
This looks like a lot of work.
Are you thinking what I'm thinking?
Let's hack an exoplanet. Hi, I'm Katya.
And I'm Ali. We're from ESA Education.
We need your help to investigate these exoplanets, some of the oddest planets orbiting other stars in our galaxy.
The European Space Agency developed satellites that study exoplanets. One of those satellites is called Cheops. You'll hear more about Cheops in a little bit and how you can use its data. Yes, you heard me right. You'll use a satellite's data for your very own school project.
Are you ready to be a space detective and hack an exoplanet?
Let's start from the beginning. What exactly is an exoplanet and why do we study them?
I know someone very special that can help.
My name is Didier Queloz. I'm working at the University of Cambridge in United Kingdom and at ETH Zurich. I'm professor of physics and my activity is essentially to detect planets and to find how they look like. An exoplanet is a planet like in the solar system, but there's a big difference. This planet is not next to us. It's not orbiting our sun. This planet is orbiting another sun. That's what we call stars. So an exoplanet is a planet orbiting another star. And they're very, very far away and they're difficult to detect. Well, the first things that we want to understand is why we are. Why we are the way we are. Why the solar system is like that. And until not so long ago, we thought that we were the only one. Not any other planet had been detected on other stars. Well, a bit less than 30 years ago, with my supervisor, we made the first evidence public that there are other planets on other stars. And now it's pretty obvious. We know there are plenty of planets orbiting other stars. But how are exactly these planets? What do they look like? Can you tell us a bit more about the structure, the size, the mass, the atmosphere? And this is what we don't know. And right now, there's a lot of programs, there are a lot of telescopes, machines that are trying to understand that. It's a big question that relates to us, because at the end, we want to understand ourselves. Why the solar system is exactly like that? And why do we have the Earth like that? Because having the Earth like that means we have life. So it's all connected to understanding our place in the universe.
Now that we know what exoplanets are, we need to find out how we can get more information so we can profile them.
I know an astrophysicist we can call.
Hello, Kate Isaak speaking, Cheops project scientist.
Hi, Kate. We have 2 exoplanets that we need to profile. Any ideas how we can do that?
Hi, Ali. Yes, I think we can help there. There are 4 main ways in which we find and study exoplanets. The first is direct imaging. As the name suggests, we actually take a picture of the exoplanet. It's not easy, though, as the stars are typically much brighter than the exoplanets.
And what are the other 3 ways?
The 3 remaining techniques study the exoplanets indirectly. Astrometry and radio velocity measure the wobble in the properties of the star.
Wobble? What do you mean by wobble?
Yeah, wobble is a bit of a funny word to use. The wobble is caused by the pull of the planet on the star as it moves around its orbit. Astrometry measures the changes in the position of the star on the sky, and radio velocity measures the changes in the light signature of the star.
So what about the last technique?
Interesting. This is called transit photometry and is the most commonly used technique to discover and study exoplanets. Here we monitor the light from the star over time and look for the dip as the planet moves between us and the star. The size of the dip depends on the size of the exoplanet and of the star. The bigger the exoplanet compared to the star, the bigger the dip. We learn a lot about the exoplanet and it's also its host star when we use this technique.
Interesting. So which technique can we use to profile exoplanets?
Well, we use transit photometry on the Cheops satellite. The name Cheops stands for Characterizing Exoplanet Satellite. The mission has been designed to study exoplanets that are already known and to learn more about them. Since its launch in December 2019, Cheops has studied several hundred exoplanets, some large, some small, some hot, some cold. It's made some very surprising and interesting discoveries, including finding previously unknown exoplanets.
So could we use Cheops to observe our exoplanets?
Yes, you'll be able to use the light curves that we get to help solve your case. I warn you though, it's going to take a bit of teamwork to hack the Cheops data.
Great. We'll collect the details and get back to you.
Okay, great. Looking forward to hearing from you then.
Now that you know what an exoplanet is and how we can use the data from satellites, let's find out how you can help us solve this case. The data we collect with satellites are like fingerprints. At first glance, they all appear very similar, but if you look very carefully, you can identify certain characteristics that are unique to your exoplanet.
We're going to point Cheops to exoplanets, unlike anything you've ever seen. Target A will be the giant Kelt 3b. This exoplanet is unlike anything we have seen in our solar system. It's a large, puffy gas world orbiting very close to its host star. It's even bigger than Jupiter, the biggest planet orbiting our sun. And because it's so close to its host star, it's very, very hot. In fact, it's so hot on this planet that there are some stars where it would be possible to go to cool off. We call these hot, gassy planets hot Jupiters.
Cheops will then turn its eye towards target B, the almost tropical TOI 560c. Compared to Kelt 3b, TOI 560c is almost tropical, though still too warm for we humans to go there for holidays, since it's still hundreds of degrees Celsius warmer than Earth. This youthful exoplanet is over 2 times the size of the Earth, and we believe has a similar internal structure to Neptune. Because of these similarities, we call this type of exoplanets a mini Neptune. Target C is the unusual planetary system K2-141. Unusual, at least according to the standards of our own solar system. This planetary system is composed of 2 exoplanets, which are closely orbiting the star K2-141, an orange-colored star that is smaller and cooler than our Sun. The inner planet, K2-141b, is slightly bigger than Earth, and also like Earth, it is expected to be a rocky world. We call this type of exoplanet a super-Earth. But these are its only Earth-like properties. K2-141b orbits around its host star every few days, and its surface is so hot that it's most likely covered with melting lava. A walk with your friends around the neighborhood would be impossible there. The second exoplanet, K2-141c, is a gas ball. This exoplanet is a small gas giant, roughly 7 times bigger than the Earth, more like a very large Neptune or a small Saturn. And, although much bigger than its companion, it's very shy and much more difficult to spot in its tilted orbit. Will you be able to detect it?
Now, we want you to use your detective skills to investigate these targets by joining the ESA Education Hack an Exoplanet.
For this challenge, you will analyze data from Cheops to profile our mysterious exoplanets, Kelt 3b, TOI 560c, and K2-141b and c. Head over to hackanexoplanet.esa.int and become an exoplanet detective. Complete the quiz and other activities to receive your badge. In the meantime, we'll be busy. Cheops will observe the targets and collect data for you to hack.
Stay tuned for more information. See you soon.